Good day. Columbus's Johnny DiLoretto is on hand this morning to learn the new technology. He's live at the Advanced Computing Center for the Arts and Design, and he's on the Ohio State University campus. Johnny.
Terry, yeah, and this is Brian Klein. He is actually going to be doing an internship this summer and fall at Pixar. So Brian may be, you know, designing the computer animation that my kid's going to be forcing me to watch 100 million times. Brian, you have come up with this. It's called the Interactive Evolutionary Design application. Can you demonstrate it for us?
Sure. Actually, so what we do here is we try to use evolutionary tactics to kind of like explore designs. And for example, if you look over here, what do I mean by that is if we have two faces, say like a mother and a father, and we kind of breed them, kind of like, you know, to create children, what would their offspring look like to get new faces? So we're kind of like, you know, mixing up the gene pool. So there's an example where we're going to use faces. So if you use this application for faces, you're going to get a population of faces.
Cool.
And then you can also use it to design lamps.
So you're like kind of taking the features
chairs
that you find kind of appealing, and then you're kind of saying, okay, I'd like this one, I like this one, and I like this one, and then your program will kind of
mix them all together and see what we got.
So I pick some faces?
Yeah, I got a quick setup here for you to choose. So what we have here is the face demo. And if you want, go ahead and choose which faces you want to make to the next population.
I like the droopy face.
This guy here?
Yeah.
Any other ones?
I like the squishy face.
All right. And one more.
And I like the round face.
The round face. All right. So these are going to make it to the next population.
Okay.
We're going to see what their children would look like.
Okay.
And here we go. So we have some more faces.
And do I pick some more?
Sure.
Kind of in the similar ballpark, right? This guy.
All right.
And this guy.
Okay.
And this guy.
All right. And let's pretend like they're close to a nuclear power plant.
Okay.
And we're going to give them a little bit more mutation going on.
All right.
So.
And then we have to wrap as soon as
and
you're
their
done.
children
So let's see what they
look like that.
This is what they look like.
Sure.
Okay. So check that out. Interesting. And then you could just keep going, narrowing it down and down until you have the next $100 zillion Pixar hit
until
character.
you find your perfect face or chair or lamp or anything.
All right. Thank you so much, Brian. Good luck at Pixar. We got more at ACCAD, more a little sneak peek at their open house and all the work the students are doing here. That's right, Kent. Why we're here is because they're having an open house Friday, which I think is pretty cool. And you're going to be able to see little animations like the one Beth Albright worked on, Drip Dry. It's a little cute little, well, it's kind of Pixar-ish, right?
Well, we'd like to think so.
Yeah, I mean, right down to the music there. That sounds kind of like the music that we're going to hear in Ratatouille, which is by Brad Bird, who you're a big fan of.
Yes, I am.
Tell us a little bit about how you put it together.
Well, there were 6 of us working in a group together, 2 students from ACCAD, design students, and 4 computer science engineering students. The computer science engineering students wrote procedural code to drive some elements, and the ACCAD students animated other characters by hand and did the modeling and rigging, etc.
And it's basically, it's a little molecular water guy versus a very nasty sponge. That sponge needs to be put in the microwave, Beth. And you guys, like, you know what, seeing something like this, it's, oh, and here we go. Here's your Matrix reference.
Yep.
Right? And that's called bullet time.
No current film is complete without a Matrix reference.
Yeah, right. You need that. And he explodes. I mean, how time-consuming is something like this?
The 6 of us spent 1 quarter, which is 10 weeks, working on this from start to finish, from concept to what you see here.
So 1 quarter. And does that give us a kind of sense of the scale that these bigger animated movies work on? I mean, how many animators would it take for Pixar to put together something like hundreds?
Well, hundreds of animators work for years to make any of the movies that you see.
Really?
So, yeah.
Including some of the ones coming out like Shrek and Ratatouille and all that stuff?
Most of those take a minimum of 3 years, if not.
And your dream job? You want to work at Pixar?
Well, it'd be fun.
Well, let's hope Brian Klein gets in. Let's hope they're impressed with him enough, and then he gets in there, opens the door, and you get in. Okay, thank you so much for showing us your animation. We got more at ACCAD, more behind the scenes look at their open house. This is Matt Bain, and he's a student here, and he's come up with a music software program that, well, Matt, I don't know, I'm dumb. You explain it to me. Tracks pitch.
It tracks pitch, it tracks beats, it'll track just about anything you would want in a piece of music over the course of time.
Check this schematic out. Look at that thing.
It's a whole bunch of wires, a whole bunch of mess there, I suppose you could say. But it's just showing you the fact that it's able to track beats over the course of over the frequency, I guess, from the lower to the higher pitches that exist as Johnny sits here drumming away. And then this entire thing actually gets fed into a different program, which converts the whole thing into a 3D animation.
And now if I make sounds into this microphone, it will...
it's going to track in the size. Yeah.
Blah. Blee. Oh, see how it turned purple when I went... Blee. Right?
Mm-hmm. Yeah, that's correct. The higher you go, the higher up in the visible spectrum of light it goes.
Okay, let me try this. Yeah, this is my deep voice here. Mm-hmm. And then higher. Higher! Higher! How about that?
That's very good.
Yeah. Here, you do a little demo.
Oh, no. My singing's a little off. La, 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 la.
There you go. Nice little falsetto. All right. Now, quickly tell us, Matt, what this might be used for.
Well, the ideal goal for this is to automate Fantasia someday, where you could have like a large orchestra or something like that, and you could project something behind them where all this stuff would unfold in real time. So you wouldn't need to have necessarily a whole team of animators working constantly to build what Fantasia was, which is beautiful by all means, but this could just be deployed instantly and would go in real time.
Excellent. Well, thank you so much for sharing it. You wouldn't even need a whole orchestra. You could just have me do all the parts, like
the one-man band.
How about that? Okay, come back. We got more at ACCAD. This is Lane Kuhlman, and she has the Minority Report glove, but it's not quite as dramatic as all that. Explain to us what you've come up with, Lane.
Well, this is a data glove, and I'm using this to control a virtual character named Ava, and I can make different.
Ava.
Her name's
is that short
Ava.
for Avatar?
No.
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 Okay. Avatar. Go ahead.
Well, I can use different gestures to make her move. So if I make, for example, I can rotate my wrist, and that makes her rotate. And then when I make a signal like this one, which is for walk, well, she's jumping.
Sign language, or is it a signal? Is it an actual?
It's actually like there's gesture codes built into this device. So for example, like you just saw, I can make her jump. She can even go for the couch. So if I can turn her around, and if I'm near something like the couch, and I make a sign for sit, like this, she'll actually go to the couch and sit down.
Oh, and she even looks behind her to make sure she's not sitting on the remote.
Right. And she can actually run, too, and jump. I can make signs for jump, and she'll jump over things.
That's pretty cool.
That's how it works.
And it streamlines the whole mocap suit thing that I was wearing at the beginning, right?
Yeah, you could actually use this with mocap, and it would recognize all your
Is that right?
gestures.
One suggestion.
What?
You might want to get that everlasting gobstopper off of her head. What is that hat?
Well, this was kind of a pre-rigged character that came with the software.
You didn't design the character.
No, I didn't. But,
Okay.
So
Right.
I'm learning to rig my own characters. So
Good.
hopefully I'll be able to make my own soon.
Because we don't want any more tie-dyed shorts and
Right.
gobstopper caps. Thank you so much for demonstrating that. I'm Johnny DiLoretto. I'm live on West Campus at the Advanced Computing Center. We're looking at what the students are doing. This is Tyler Ayres and his animation called
Red and blue.
Red and Blue. And it is about two balloons kind of just going at each other, right? There's the red one. And how long did it take you to put this together, Tyler?
I've been animating for about a year now, and I've done all the production myself, or pretty much all of it myself. And it's a story about how a little blue balloon can overcome a bully.
Okay, great. Thank you so much, Tyler. We'll see you back here on Fox 28. Good day, Columbus. Yeah, Kent, this is actually what this is going to be. It's well, Fran Kalal, she's the designer of this application. She's getting it ready. I had to be calibrated. This hat I'm wearing, it's all about being calibrated. And this program will teach a kid, not necessarily, I don't know, like hand-eye coordination, but more like assertiveness. Is that what you're after, Fran?
Right. This will teach a child how to be assertive if someone cuts in front of you in line.
Oh, okay. Which happens all the time.
All the time.
Okay.
Okay.
And there's you can hear, there he is. There's the cat right there, and he's standing in front of, or she is standing in front of an aquarium. So let's say I'm a kid, you're a kid maybe, and I want to see the fish. And I want to look at the cat, or look at the fish. The cat will move in front of me, right? Or is it maybe the light is screwing up? Oh, there he goes. There he goes. So like I would say, excuse me, pardon me, I would like to see the fish, please.
I'm sorry, you can go now.
I'm sorry, you can go now. That's what the cat says. Yeah, see, isn't that nice? And then I can look at the fish and they'll follow me. They'll follow when I move my head. The fish go up and down and around. That's pretty cool, friend. Frankly, I just say, hey cat, beat it, scram, or I'm gonna put a foot on your head.
If you're gonna be mean, I'm not gonna move.
And that's what would happen, right? That's what you would hear. Okay, cool. Thank you very much. This is Steve Conroy. He is another student here, and he's worked on a group project like we saw earlier in animation. You want to go ahead and show us, Steve?
Sure. This is from the animation production class at ACCAD. This is a group project where we spend the whole quarter going through a production pipeline like a typical animation production house would.
Entitled Spliced.
It's Spliced. It's about a young child receives a mysterious toy, and the pieces form into a DNA, and as he starts to manipulate it, strange things start to happen.
That's great. It actually looks like the baby version of the nasty kid in Toy Story.
It's similar,
right?
Yeah.
A little bit, right? Maybe. But I want to make sure that everybody knows that there is an open house here Friday from 4 p.m. to 7 p.m. Everyone is invited. Of course, everyone except little destructive guys like this. And what's spectacular about that, what's really fascinating is this state-of-the-art stuff goes on here, Steve, right? And you know, this is a chance for everyone to kind of see what the students do here. People like Steve may go on to work for big animation houses or video game producers, right? And so definitely want to check that out. Friday from 4 to 7 p.m. right here on West Campus at ACCAD. Put in his nose. Now it's getting disturbing, Steve. Yeah, I see that. All right. Well, thank you so much. I appreciate it.
Okay,
Thanks for sharing your project with us. And thank you, everyone here at ACCAD, for opening your doors this early and showing us all this spectacular stuff. Back to you guys.
That is a little disturbing there, with the nose and all that. Thanks, Johnny. We'll get one last visit with you in just a moment.